To the cloud. Good
Alrighty.
morning, everybody. Going to introduce Jackson here with Sentinel Fertigation. He's going to review some trial data and stuff like that. So hoping we had a few of our farmer trial members that actually did the trials on, so we'd get some good questions, but we'll think of something here. So with that, Jackson, you want to take it away?
Absolutely. Thank you, Lauren. And yeah, today what I'm going to do is go through just a little bit of the background of our technology. For anybody that's not familiar, I'll probably breeze through that really quickly, cover our overall commercial and benchmarking results just on a couple of slides, and then dive into the Iowa data pretty heavy. And there's one case study from Nebraska I want to pull in because I think it's relevant to the folks over in Iowa. So that's what we'll do today. So again, what we do at Sentinel Fertigation is we provide real-time crop nutrition intelligence. And this is specifically for nitrogen management right now. What we do is we turn data, most specifically imagery, weather, operations, and other data into insights that isolate the impact of nitrogen on yield potential. And also we deliver measurements and forecasts of nitrogen sufficiency and nitrogen demand. From those insights, we're able to derive recommendations that can be either as simple as you need to apply or not apply. And if you do need to apply, this is the flat rate that you should apply to the entire field. And then for folks that do want to pursue variable rate applications, we do provide variable rate prescriptions. And we deliver our recommendations and insights really via email and text right now. And we're going to continue to do that into the future. One of the most critical differences in N-time versus other nitrogen management solutions that you might see out there is that we actually track crop nitrogen sufficiency in real time by date. So the graph that you're looking at is what we call our sufficiency index trendline graph. The one value that you see there is basically 100%, so that means the crop is 100% sufficient for nitrogen. The 0.85 is 85%, so that means the crop is 85% sufficient for nitrogen. And the two different lines that you see there are the sufficiency of different zones in the field. Each one of the black vertical lines is an application that was made on this particular field during the 2024 growing season. This is a field that had nitrogen applied via fertigation in Nebraska. And what I think is really cool about this data set is that you can see after each one of these applications that there was a positive response in sufficiency after each one of these applications. There's a little bit of variability in the timing over which that sufficiency was seen, but you can see the response in sufficiency. And so our goal with our algorithms and recommendations is to drive crop nitrogen sufficiency into the optimum zone, which is a little bit different for every single crop, but it's somewhere between 95 and 100%, where we'd like to keep the sufficiency for the crop in that range. This is very similar if anybody has ever dealt with soil moisture probes. I know, we have a lot of rain-fed growers in the audience here, so it may not be the most common thing, but if you've ever dealt with soil moisture probes, this is a very similar concept where we're trying to keep that soil moisture in an optimal zone. We're trying to do the same thing with nitrogen. This past year, we launched N-time Advanced, which is what provided the variable rate recommendations. We were able to provide those in zone, VRI or VRF formats. And then as we look forward in N-time Advanced, we're also adding a scenario simulator with comparisons for base rates and full season nitrogen applications, as well as an ROI-based justification tool for in-season applications. We did test N-time Advanced for the first time in Nebraska this year, and I want to share some of those results with you too. So overall, on our 2024 commercial fields, we had 367 fields in the system commercially this past year, just a hair under 40,000 acres in the system. And across basically 30% of those fields, we were able to get complete data set back. So verified nitrogen application logs, verified yield data in digital format, so on and so forth. And this is what we found in those commercial results. We averaged 242 bushels an acre on 178 pounds of nitrogen applied for 0.75 NUE and a partial profitability that was $36.65 ahead of what was expected on the farm this year. And just to kind of give you a baseline of how we do these comparisons, the expected yield and nitrogen applied values are reported by the farmer. In the case where we have digital data available for multiple years in the past, we actually set the expectation of yield based on the average of that yield over the course of however many years of digital data that we have. So we do try to validate that with digital data where possible. But overall, what this commercial data suggests is that we were able to at least maintain yield, if not increase it a little bit, reduce nitrogen applied, and ultimately drive higher profitability and efficiency. So getting into the benchmarking results, what I like about benchmarking is that we're comparing our management versus grower management on the exact same field. And so it kind of cuts through any of the field-to-field variation that you might have in yield and nitrogen use efficiency. It also cuts through other factors like seeding rates or fungicide applications, pest pressure, anything like that. And so what we saw on 12 sites in 2024 in Nebraska is that we were able to yield on average 236.4 compared to 235.6 for the grower. So again, negligible difference in yield. We applied 24 pounds less nitrogen, had a higher NUE by 11%, and improved profitability by a little over $18 per acre. This is fairly consistent with what we've seen over the past 4 growing seasons. The only difference being that we actually encouraged more nitrogen application in 2024 than we had in the previous 3 growing seasons. And also saw a little bit higher yield values than what we've seen in the past. So that's Nebraska, fertigation, and then also our commercial results, just to kind of give you an idea of what we've seen from performance in 2024. So now let's dive into what we did in Iowa this year with Ag Ventures Alliance and Ag Launch. So what we were looking at in 2024 is what we're calling our all-in capabilities. And these all-in capabilities are designed to serve nitrogen management needs for either supplemental irrigation, complete irrigation, or more importantly, rain-fed corn growers. So what we did in 2024 is developed a prototype that was along the lines of what we were going to be releasing in 2025. We used a 2-week weather forecast to drive near-term nitrogen demand estimates. This is probably our biggest limitation right now because we were only using 2 weeks of weather. What we did to get nitrogen demand beyond 2 weeks from when we were making the recommendation is we benchmarked nitrogen uptake and fertilizer fractional contribution to that nitrogen uptake versus a credit-based algorithm, and we used that to assess long-term demand. So again, we used a model with weather forecasts for 14 days following the recommendation, so the near-term nitrogen uptake, and then we used a combination of that model and a credit-based algorithm to assess long-term demand on the field. When imagery was available, we used imagery to quantify the 1-week nitrogen demand and kind of correct the model. The model filled in the gaps for the rest of the 14 days, and then we used the credit-based algorithm plus the model for demand past 14 days. And in cases where we did not have imagery available, whether that was because we didn't get a boundary in time to get imagery started or whatever the case may be, we used the model to quantify 14-day nitrogen demand and then leverage the model plus that nitrogen credit algorithm to get demand past 14 days. I know that's a lot of detail there, but I wanted to let y'all know what it was that we were actually executing on in 2024. So to get into some actual results here, we had a field with the Hannas, and this was a field where we did not have imagery available. We simply used the model and wanted to test how well that model could perform in terms of predicting the appropriate nitrogen rate on this field, separate from the imagery. So that's what we decided to test on this field. The way that we went about doing that is the model recommended a rate for the field, and then we decided to bracket that rate with 2 different rates in strips in the field, one that was 30 pounds higher than what the model recommended, and one that was 30 pounds lower than what the model recommended. So we got to see a spread of about 60 pounds of nitrogen in the field. And so as you can see in this image at the bottom right-hand corner of the screen, we had 2 different strips in the field, a pair on the north side that had that high and low rate plus the model suggested rate just right outside of that pair. And then on the south half of this field, we also had the model rate to the west, and then paired high and low nitrogen rates, with high being in the green, low being in the red, in the center of the field. So that's how we were testing the system this year. This is a corn crop, 105-day relative maturity hybrid that was planted here. We had a planting date of May 13th and a seeding rate that was just a little bit shy of 34,000 seeds per acre. As you can see, we had a little bit of soil variability here. We had clay loams, and then also a complex in the field. Again, we had no imagery or plots, so I'll get into the plots later, but our technology typically relies on plots to calibrate imagery, so we didn't have any of these plots in the field prior to the side dress recommendation, and we didn't have imagery, so we relied on the model only. And importantly, the model was not yet at this point configured for spatial variable rate application. So we were only able to recommend a single rate for the whole field, which I think you'll see why it's important later on. On May 13th with planting, Hannah's applied 64 pounds of nitrogen per acre with 32% UAN. And then on June 18th was when we made this V6 side dress application. It might have been a tad bit before V6, but I know V6 was kind of the target that we shot for. And then the rate that was applied there, if I can move my picture here, was 101 pounds of nitrogen per acre. So here's how the season progressed in terms of nitrogen uptake, precipitation, and then our vegetation indices. The main reason why I'm showing this is I'm trying to get an idea of how close was our model to estimating the correct growth stages in the field, and how well does that model align with what we did see in imagery once we got imagery activated in terms of crop progress. What we can see here is that we had a fairly rainy May, June, and early part of July. And as we got into August, September, obviously it dried out quite a bit. And so you can see the lack of precipitation there. I think that aligns with what I've heard from folks in this area. We can also see that in these dotted lines here, we're marking key growth stages. So we identified pollination using the model right around the 2nd of August. So you can see that over here in the table on the right. I think this is the model identified pollination just a little bit late here. Based on what I'm seeing in the imagery, we probably had pollination about a week or so earlier. When we typically identify pollination in imagery, we see a flattening of the vegetation index curve, and it looks like that's happening sometime in late July rather than early August. So I think the model might have been a little bit late in terms of predicting growth stage here, but we did have early grain fill at R3 estimated on August 16th, late grain fill on September 17th, and maturity on September 28th. So I think these dates align fairly well just based on this pollination date. I just think the pollination date is probably a little bit late, which shifted all these subsequent dates back. So overall, I think it's solid model performance given that we had no in-field checks on this. So moving in the right direction. Any questions or thoughts on anything I've presented so far on this site?
I guess I've got one going back a little ways, where your averages were around that 3/4 of a pound per bushel. Could you speak to, I guess, across that system, how much of that was corn on corn versus corn on bean acres? Just because I think that would be pretty relevant.
Yes, Joe, honestly, I need to go back and assess that and get an idea of crop rotation, and I can do it more easily in our benchmarking results than I can in our commercial results, just because for whatever reason it's hard to track down that crop rotation data. I'll work on it. I know in our benchmarking trials through last year, we saw roughly 2/3 of the acres were in a corn on corn rotation, and 1/3 was in a corn on beans rotation. And we're averaging in those benchmarking trials a 0.59 NUE. What we typically see within corn on corn is a 0.6 NUE is what we've averaged in our benchmarking trials, and then following beans we're at like a 0.51. So there definitely is a variation following beans with a higher NUE following beans. Other questions on anything to this point?
How much do you rely on going back in history and looking at the fields? I had a situation where they tried to sell me some stuff using that, but we had just tiled part of the field and adjusted the fertilizer. So the previous years, it kind of wasn't valid.
Right. We don't rely on history at all for our recommendations, Keith, to be completely honest with you. We rely on imagery first and foremost at this point, and we use basically a high and a low nitrogen plot to calibrate the imagery. And we put that out in the field with a fertilizer pass. So say you're putting on 100 pounds prior to planting, we tell you to raise it to 160 in certain areas, drop it to 70 right next to it. And then we would look at those plots to see how that crop is responding in that year to those conditions in terms of nitrogen sufficiency. So we really do not rely on historical information at all in our models. Definitely a big difference between some of the other solutions out there. So getting into some performance results on this particular site. So what we did here is we went in and we evaluated yield, profit, and NUE, which are the three major metrics that we measure to assess performance in the high, low, and Sentinel model only recommended rate for the field. The high nitrogen rate in this field was 196 total pounds of nitrogen. The Sentinel model recommendation was 165 pounds of nitrogen, which was at 64 plus the 101. And then the low nitrogen rate was 133 pounds of nitrogen per acre. What we're doing here is we're looking at the north side pair of plots. You can see that we have our sufficiency index trend line over here on the left-hand side of the screen, and this sufficiency on the field was bouncing basically between 94% and up to a high of about 99% after this application was made. So we were only able to monitor with imagery after we put these high and low into the field. So we were bouncing between those sufficiencies all the way to September 15th. The high plot yielded 155, the Sentinel plot yielded 100 bushels per acre, and the low plot yielded 126. What this tells me, looking at the correlation here, and I know this is profit, but we can also see that the profit numbers are highly related to yield. The correlation here suggests that these north plots had very little response to nitrogen. There was some other yield limiting factor besides nitrogen in the field, just because we don't see any sort of consistent trend. The other challenge with this is we actually had a change in soil type. If we go back here, you can see that where we had the Sentinel rate up here on the north side of these two plots had a fairly significant soil type distribution compared to the high and the low plots here. So it's not exactly the best comparison between these rates. Now, if we look at our south plots, we see a much better SI curve. It's much tighter with some lower variation. You can see that the sufficiency declines consistently all the way to September 15th in this field. And we see a much tighter correlation between yield and nitrogen applied. So in these plots, we had the high plot at 197 pounds of nitrogen per acre. The Sentinel plot was at 165 pounds, and the low plot was at 132. I've honestly never seen an R squared of 1 in nitrogen data, and there are several in this presentation. So I don't know if that's just because I'm used to dealing in irrigated systems where the water variation is taken out. So there's other things that are causing the variation, so there's more noise. I think in this case, with water being the primary limiting factor, it actually may tease out a little bit clearer distribution of nitrogen at those different rates. So what we saw is 153 bushel per acre yield in the high, 140 bushel per acre yield in the Sentinel, and then 122 bushel per acre yield in the low plot for a 1.29, 1.18, and 1.08 NUE respectively. And the highest profit was seen at this highest rate, so 30 pounds ahead of what the model recommended for this field. And again, I think this is a much better comparison because if we go back and look at our soil map here, you can see that there's a pretty significant swath right in the middle of these plots that shares the same soil type. So our Sentinel rate again was running right through here, and so we were able to get a nice chunk of comparison in this major soil type for the field, as well as a good comparison across this soil type right next to each other, as well as the pink and this lighter gray. So this is a much better comparison than the north side. So if we track crop progress through the growing season using the sufficiency index, again, you can see that that's the south pair of plots has a much tighter distribution within the sufficiency index. You can actually see sufficiency increases following large rainfall events. So I think that's kind of interesting that you can see that spike there and that spike there following these two large rainfall events that are weather observed. Now, I don't know how much this field actually got. This weather comes in at a 25 square kilometer grid right now. So it's something that we are seeking to improve, right? But it does seem interesting that there's a high correlation across both of these and a spike following those rainfall events. Within 14 days of the side dress application, after we turned on imagery, our imagery triggered for more nitrogen to be put on the field, right? What this tells me is that if we'd had imagery going and we'd had plots in the field prior to that side dress, we actually would have been able to correct for that crop response in the model and get to a more appropriate rate for the field. Based on our July 1st imagery, which I'm estimating is approximately V10, our model recommended 3 different zone rates, with the highest being at 54 pounds of nitrogen per acre. On July 25th, given that we had not intervened at all, we were still triggering for an application. This was around R1, R2, but as you can see, the rates declined quite a bit in terms of what we were recommending. The reason that this happens is our algorithm is saying once we've passed that high nitrogen uptake and we've gotten into the later growth stages of the crop, that nitrogen is not going to be as beneficial, so let's reduce those rates. It could still benefit from some nitrogen, but it's not going to benefit from all of that nitrogen. So if we add all this up and we take our yield equation that was produced by looking at the different yield responses to different nitrogen rates, what that yield equation suggests is that the economically optimal nitrogen rate for this field was actually 256 pounds of nitrogen per acre. I kind of find that a little bit hard to believe. I would think it would taper off a little bit more above 197 pounds of nitrogen per acre. What our imagery suggests is that up to 219 pounds of nitrogen per acre would probably have been optimal on this field from a profitability standpoint. So that's what the retrospective analysis of this field shows. And that kind of aligns, right, with this graph here, where we're seeing that the profitability is increasing and should continue to increase at this similar trend beyond 200 pounds of nitrogen per acre applied. So what I'm saying here is our imagery suggests that right here at 219 pounds of nitrogen per acre would have been the most profitable rate for this field. If we look at performance across different soil zones, Zone 4 actually showed that the Sentinel rate was most profitable. This was the Lester loam in the field, 33% of the field. And what's really interesting about this is the way that our model worked in 2024 is we basically took a point centroid of the field boundary and we used that point to inform the soil type that went into the model, right? Because it was not configured for variable rate. The point that was used to run the model actually landed in Zone 4. So what this tells me is that the model did a really good job of handling Zone 4, which if we go back to our management zone screen here, Zone 4 is this blue zone right here. So the point that we used in the dead middle of the field was right here, right? So the model did a really good job of assessing the nitrogen demand within Zone 4, but it did not do a good job in the zones that it was not using to produce the model-based rate. That's where the imagery would have been extremely useful to correct for demand in those other zones and manage to the demand in those zones. So, few conclusions. More nitrogen would have paid in most zones in the field. We did detect a declining sufficiency within 14 days of the application using imagery. The most profitable N rate for the field likely ranged from 165 to 219 pounds of nitrogen per acre. 165 was most profitable in Zone 4. Up to 219 pounds of nitrogen per acre would have been demanded in other zones, we think, based on imagery. And the enhancements that we have already made to all in would have improved this outcome, we believe. Any questions on this field here?
Hey, Jackson, Andrew here. Yeah, I was
Andrew.
just gonna also add in there too, our weather up in that area this year was from one extreme to the other. We had, a lot of rain at the beginning to about August, everything just shut off. So that's, I don't know how that plays into everything too, but that was big this year.
For sure. And that's exactly what the precipitation data shows, Andrew. So I'm glad that's what y'all observed too. It's always a little bit challenging with weather to trust that what it's showing is accurate. And when we don't know that the depths and everything were completely accurate, I'm glad that trend is at least aligned with what y'all were seeing out there. And I think one thing that's important about precipitation and kind of the way that we're thinking about this as we get into rain fed is there's a period of time in that corn plant's life where it's going to take up the vast majority of its nitrogen. And so the rainfall and nitrogen availability in that portion of time goes a long way to setting yield potential. So if we had good moisture availability during that time, in that late June, early July timeframe, then it's likely we could have made some hay, and even with that drier spell later in the year, not allowing for as much nitrogen uptake. So I definitely think the weather dynamics played a pretty significant role here, Andrew.
Do you
Jackson.
review soil tests and stuff? What I'm wondering is the sulfur component. You know, if the field is low in sulfur, it doesn't matter how much nitrogen you put on and all that. That, you know, could skew your results if you weren't monitoring for that.
Yeah, yeah, that's a good point, Keith. And we actually, I know Andrew sent over the soil test. I should have included that in the presentation. I just honestly forgot that we had those. So I'll take a look at those and maybe follow up with Lauren and can provide some detail there if that helps.
But going with that, Jackson, would there be a benefit to compounding effect? I mean, the more data and more years you put into this model, will it get more accurate?
Yes, yes, it will. And we actually, so we're still going through the paperwork phase, but we just got an SBIR grant that is going to build out more of this. And one of the objectives of that is to build an AI, a field-specific AI model that basically learns from our system that's observing the field and from the model that's modeling growth on the field, combining those two factors to build a field-specific crop and nutrient dynamics model. And that's where we think putting more data into the system year over year, observational data into the system year over year, is going to just improve how we're able to forecast demand on each field.
You had mentioned the weather model data you're using at this point is a 25-mile grid. Any thoughts to in-field weather stations for ground truthing of that, or I guess how that might affect or improve accuracy?
Yes, 100%. Yeah, so Joe, so we've got a 25 square kilometer grid. You don't know what's going on in there. You know, there are a bunch of fields that are contained within that grid. I've been in fields before where it's raining on one half of the field, not on the other. I mean, we know it's going to be spotty and slightly incorrect. We've had some early conversations with some weather station companies to kind of assess, you know, what is the viability of getting weather stations out in the field. I was actually surprised at how many weather stations they already have out with growers, which I didn't realize. So if there's high demand for that, I think that's certainly something we could plug into. We've also looked at a couple of other weather providers that are on a half-mile grid, and we think that's the direction that we're going to migrate, is using half-mile grids. That way, we're at least getting to field-specific weather in this model. I'm going to keep rolling here, and we'll probably have some additional questions. Lauren, this is your field, so just, you know, correct me if there's anything that I'm not characterizing here, but based on our conversations, I think this is fairly accurate. And the as-applied data that's in John Deere. I do have one question about that for you that I'll ask on the next slide maybe, but this was planted on April 25th. This is a Pioneer 0421 AM hybrid seeding rate, just over 34,000 seeds per acre, based on the data we have in John Deere. Soil types here are loams and a Clyde-Floyd complex. There seems to be a pretty significant amount of variability in the field just from the imagery standpoint. I assume a lot of that is due to elevation and possibly some subsoil characteristics in this field. And Lauren, I had you at 30 pounds of nitrogen per acre at planting with 28005, and then we had you at 111 pounds of nitrogen per acre target rate for your July 4th application with 32% UAN. Is that accurate?
Yes, I think I know where you're going with the questions, because something shows up different on John Deere ops than what the
Yep.
prescription in that should be. So, but
Yep.
that's when he went back and filled in that last little strip there, the rates really went off the chart, but
Got it.
actual should have been correct yet.
Okay. All right. So the way that we've run the analysis, and that's exactly what I was going to ask, because the John Deere had it at 444, and I was like, that's not what Lauren, that's not what Lauren's putting in his high nitrogen rate out there in this field. So that's what I've got listed here, just because it's in the applied. But the trends are going to be the same, whether we shift this down, to the actual target rates or not. So I want y'all to pay attention to the trends here and not so much the exact numbers, because they'll be the same. So what we saw in the high, middle, and low rates in the field is that there was no variation in yield across this field. So the low rate was basically the target rate for the field, is what we saw, and this came out to 142 pounds of nitrogen applied in the field. And the Sentinel rec would have landed right around that rate. And so basically what the data suggests here is that there was no more nitrogen needed than what the target rate was for this field. And that the target rate and Sentinel rate were pretty much neck and neck in terms of profitability, just using the model. This was no imagery. And these are both very high correlations between nitrogen applied and yield response, as well as economically optimal nitrogen rate and yield response. When we're comparing these high and medium rates within the field, what we see in the imagery after these plots are established is that we actually go excessive in terms of our nitrogen estimation. That's because we're using that highest rate, right, to figure out, where the crop is performing, if it had as much nitrogen as it possibly could use, right? And we see that that amount of nitrogen actually causes the crop to underperform relative to the lowest rate of nitrogen, right? So what this suggests is that the target rate for this field, that lowest rate, right, would have been the most appropriate nitrogen rate for the field. The imagery is able to corroborate that, and then the yield data suggests that that is also true. So Lauren, I guess I'd like to get your take on this and what you saw in the field when you were harvesting, and what your thoughts were about those different rates in the field.
Yeah, you didn't happen to do one of the other fields by chance too, did you?
The only reason I didn't, Lauren, is because on those I couldn't find a large enough stable rate in the field from the
Okay.
prescription. So this had the biggest area that we could use. So
Yeah. Okay. Yeah, because I mean that's the biggest curveball our soils would throw at most prescription is it's so variable, and we were running 120-foot boom Y dropping.
yep,
And but I've also seen on ours the low rate usually ends up winning.
yep,
And like I said, I know we didn't put 440 pounds or even the 300 some pounds on there, and I'm trying to
yeah.
find the actual prescription. I'm trying to look on JD Ops where I'd find that, but
The average rate for the field was all in that
yeah, well, I think
31 gallons per acre. So I think it was like
yeah, if
100.
you go to target rate, that would show the actual prescription on that field on mine, but
Yep. Yeah, and I
that's it.
think I did 111 pounds as the primary target rate on that field.
Yep.
So
That's it.
I
I
know
wish
it's
I
not a
had
perfect.
JD Ops on the laptop there, but it looks pretty respective.
Good. Um,
And what most people probably should know, this was kind of a backup plan. But that's the neat part to see, on a catch up, how we perform on a catch up late season sign on.
For sure. Exactly. And what was nice about this is we could actually go back and use a historical weather forecast from the date that we would have made this recommendation. And so it's not even using historical weather, what actually was observed. This is using basically the forecast on the date that we would have run the model, which I think I had in here is July 3rd. And so it's kind of interesting to see that we can go back, run the model retrospectively, and get fairly close to what the highest performing target rate in the field was.
Yes, and per Joe's question earlier, if you do want to play around with this, I can probably figure out how to share the actual rain data from a sensor a quarter mile away to this field. So
That would be awesome, Lauren. Because we are evaluating, weather stations, other weather data right now, and that would be very helpful to rerun the model and see how much better it gets.
yeah, this would be the same thing as a airport, which will make the radar estimates look sad.
For, yes.
I think if I look, that field had close to 65 inches of rain this year.
Yeah, and that's going to be a lot higher than what this would tracked if I'm looking at it correctly, since June 1 anyway. So there might have been more prior to June, but should be a lot higher. Cool. So that was a wide drop around V10. I think we've kind of covered all these different conclusions here. So the last one I wanted to get into is we ran a manure fertigation trial with a 360 rain system, and this was really interesting. I don't yet have hybrid planting date seeding rate, but we can still do an analysis here. We know that our plots were established with manure on 7/1/2024, and I do know this was the first nitrogen application that was made on this field with any product containing nitrogen. Was on July 1st. And our records show that we at least had a communication of an application of manure on 7/29 in this field. So what I've done to go ahead and evaluate this is just show imagery progression over the course of time and show the sufficiency that we tracked in this field over the course of the growing season with these two different plots. So as you can see here, we established our low and our high on each the west and the east side of this field. And what we did to assess is we took the yield in the area right outside of these plots to treat as kind of our zero variation. So we're going to treat our low as a -30, the area outside of those plots is 0, and the high is a +60 based on the prescription that we provided here. So what we can see over the course of the season is on July 3rd, around the time that we established those plots, we were still working towards canopy in the northeast part of the field. The southern and really southwestern part of the field was already getting towards canopy. On August 3rd, we can see that we have a much more consistent canopy in the field, but still some residual impacts of that slower canopy and possibly poor soils in the northeast part of the field. And then we can start to see some senescence beginning on September 3rd in this field. Our sufficiency index over the course of the growing season really ranged between about 95% up to 100% sufficiency on this field. But you can definitely see a divergence in the two plot pairs as we get into early September. So one of the plot pairs is staying much more sufficient for nitrogen, while the other is beginning to decline pretty significantly as we get into September. And the precipitation on this field that was measured was a lot spottier. There was a lot less precipitation in general on this field than there was on other fields that we've analyzed so far. And it seemed like the precipitation that was received based on the data we have was much more significant. So each time that there was a precipitation event, it was a larger precipitation event. There were fewer smaller precipitation events over the course of the growing season. So here are the results that we have for yield and then relative nitrogen applied within those different strips in the field, as well as moisture. And what we see here, based on what we know right now, is there's very little response to nitrogen on average across the field. The bulk areas of the field, so these are outside of those high and low plots, yielded 210 on average across the field, whereas the Canary and Reference both yielded 215 pounds of nitrogen per acre, or sorry, both yielded 215 bushels per acre with a variation of 90 pounds of nitrogen per acre between them. If we look at individual plot pairs, so this plot pair being on the west side of the field and this plot pair being on the east side of the field, the east side does show some positive response between the Canary and the Reference in terms of yield values, and the The east side actually shows that the Canary out yielded both the bulk and the reference values. So the lowest nitrogen rate was the highest yielding in that particular pair. What we don't have the advantage of with these 360 rain machines is the ability to verify where these nitrogen rates were applied in the as applied data, or at least we don't have that right now. And what I think is interesting with this is you can actually, if you were to flip this and it was actually the canary where the reference is, reference where the canary is, then you would actually get a much tighter response. So what this graph shows is if we flip the canary and reference in both pairs, we get a much nicer yield response. So it could be possible that we had those two flipped just based on not having the as applied data on this field. But you do get a much nicer response in terms of yield to relative nitrogen. And what this also shows is that for our west plot pair, we would have hit the optimal yield point where past which there's no additional yield gained by additional nitrogen somewhere with 40 pounds more nitrogen, whereas we likely could have benefited from 60 pounds more if, this is true that the canary and reference were flipped in that east pair. Zone-wise, there's a pretty wide distribution in terms of how those zones performed with less nitrogen on them, and that variation decreases the more nitrogen that goes out into the field. So I thought this was also kind of an interesting trend that there's so much disparity at the low rates, which suggests that those zones, their water holding capacity, water availability, likely impacted quite a lot how the crop was able to utilize that nitrogen. So in areas where it could utilize nitrogen better, that low rate could perform quite well. But in areas where we couldn't utilize water quite as well, the higher nitrogen rate may have performed better just in terms of getting more nitrogen into the plant. So that's what we have for this. I know it's not a perfect analysis. I'd love to dig into this a little bit more, and we'll follow up as we get more data here. But I thought this is a really cool trial to actually use in time to at least track crop nitrogen sufficiency based on manure applications from a swine lagoon. All right. So the last one I wanted to show y'all, and I think this is a really good trial, and I think is very relevant to what we did in Iowa. I've got a little bit of Iowa data after this from commercial fields, but we'll dive into this first. So this is a field out in western Nebraska, silt loams, fine sandy loams, planted on May 10th, 31,000 seeding rate. This is under irrigation. The nitrogen management scheme here was a top dress application of a urea AMS blend at a target rate of 40 pounds of nitrogen per acre, but somewhere it varied in field position from 35 to 41 pounds of nitrogen per acre in the as applied. With this top dress, the grower put in field length strips. So we had a low nitrogen rate and a high nitrogen rate in a field length strip. This is a -30 and a +60 in terms of nitrogen rate. So we had 10 pounds in the low and 100 pounds in the high. On July 2nd, this grower made a Y drop application that varied between 36 and 62 pounds of nitrogen per acre. And then on July 12th, there was a fertigation application that was recommended by us that ranged between 35 and 51 pounds of nitrogen per acre on our sectors. So the way that this field was set up, and I'll just ask you to look over at this bottom right-hand picture with me real quick. We had 4 grower sectors in the field and 4 Sentinel sectors in the field as well. And so this is how we split up the field to compare grower versus Sentinel in this trial. On the 23rd of June, so this is roughly 2 weeks after that top dress application, we triggered for an application. Going into the growing season, this grower wanted to wait until V10 to apply their Y drop application, and they wanted that to be their only application for the whole year. On the 23rd of June, they were just at about V6, maybe burgeoning on V7. So we triggered and said, you need to go now, right, for this application. They went on July 2nd, so this is the image right before they made this application. This is what we generated our prescription based on. So this is two growth stages basically earlier than they wanted to apply. So we made this prescription. You can see our prescription here in the orange, yellow, and lighter green in the field. So those 4 sectors are ours. And the grower and their agronomist built the prescription in these other sectors. So you can see that their Y drop rates were a little bit higher. Roughly 2 weeks after, we triggered for another application via fertigation and asked the grower to put on somewhere between 35 and 51 pounds of nitrogen per acre in our sectors. So they made an extra irrigation pass to get this fertilizer on, and they chose not to apply nitrogen in their sectors. They just didn't think that it would benefit their yield potential. If we look at the image on 821, we can actually start to see, though, that the Sentinel sectors are beginning to show up as greener in this field than the grower sectors. And if you look at the image on 9.8, you can start to see the Sentinel and grower sectors diverging even a little bit more. If we look at how the crop changed over the course of the growing season, these 2 black lines that are vertical indicate the dates on which the Y drop and fertigation applications were made. You can see the increase in sufficiency after that Y drop application, and you can also see an increase in sufficiency after the fertigation application. And then you see what we'd like to see, which is a declining sufficiency, right? Not going below 95% until sometime around the 1st of September, and then continuing to decline through senescence of the crop. And as you can see, there's very little precipitation here, but again, like we've seen in most of our fields, the precipitation was weighted from middle of July earlier into the growing season into June. So here are the results on this field. Sentinel recommended 123 pounds of nitrogen per acre to yield 227. The grower applied 100 pounds of nitrogen per acre to yield 209. Sentinel NUE was 0.54, grower NUE was 0.48. Difference in profitability here shown does not account for the extra irrigation pass, which would lop off $6 per acre. But even accounting for that, it's a $60 per acre improvement in profitability. And the only category in which Sentinel did not perform as well was the NUE value on this field. And we could have anticipated that there was going to be a difference in yield just based on the sufficiency in these sectors on 821 and on 9.8. And here you can see the yield ranges across those sectors for the Sentinel and the grower treatments. So what's really nice about this is there was a full comparison of both managements on this field. Probably the biggest thing that we were not able to assess is if the grower had waited until V10 to apply their Y drop on their sectors and we had gone earlier, how much of a difference would that have made? Because that's what I really would have liked to have seen, because we shifted both applications earlier, and so we weren't able to tease out that timing variable as well. But what this showed us is that timing and rate combined to have a major influence on yield and profit. So the right nitrogen at the right time is what we believe drove the profitability improvement here. I thought the other cool thing about this is it did show that end time can help us vary when that side dress application happens based on when the demand is occurring, so that we're not just relying on a predefined plan to do this. And lastly, end time does not always encourage a nitrogen reduction. The previous 5 years of research suggested that we almost always encourage a nitrogen reduction. This year was not the case. We recommended more nitrogen a lot more frequently, and I think it just had to do with our early season weather conditions across most fields. Any questions on this particular site here or the previous? Cool. So just last couple here, I know we're right on time here, so I just want to cover a couple of commercial fields that we had in Iowa. These were fertigated and side dress fields in Iowa. So this is the same field. It was split into half, 1 beans, 1 corn. As far as their previous crop, I should say. So what we're looking at here is half of the field where the previous crop was corn. This was planted on 4/23, harvested on 10/18, seeding rate just under 33,000 seeds per acre, and this is a Pioneer 0529Q hybrid, and this is in north central Iowa. The nitrogen management strategy on this field was 45 pounds at planting, 63 pounds with a 75% 32 and 25% thio blend as a side dress application, and then a urea AMS blend 10 days later at 56 pounds of nitrogen per acre, and then two in-time recommended fertigation passes of 31 and 60 pounds of nitrogen per acre respectively on this field. So what we saw on this field is that we applied 255 total pounds of nitrogen to yield 243 bushels per acre, compared to a baseline of 200 pounds of nitrogen per acre to yield 235 bushels per acre historically. So we went from a 0.85 to a 1.05 NUE. And this is all somewhat surprising. This is not stuff that we had seen before. Applying this much more nitrogen and then getting a slight yield improvement versus expectation. We did see a $12.90 per acre profitability improvement on this field. What I think is really interesting is we can again look at our yield and nitrogen applied in our high and low plots in the field to get an idea of where we landed in terms of correct nitrogen rate. And so if we look at our nitrogen applied on this field in our lowest plots in the field, we had roughly 200, this would have been 225 pounds of nitrogen per acre on the field because it was 30 pounds less than what we applied to the bulk of the field. This 225 pounds was less than what the grower typically, was more than what the grower typically puts on. So this gives us a really good check of where would the grower's typical nitrogen program have landed relative to what we applied this year. And what we can see here is that 225 pounds of nitrogen on average would have landed us somewhere around the baseline yield. So we know that at least to get to that baseline yield on average across these points, we would have needed at least 225 pounds of nitrogen per acre. So the grower's typical nitrogen management program would have come up short this year, right? And we applied 255 pounds of nitrogen per acre and landed right here in this 240 bushels per acre on average. And if you average all of our high nitrogen plots, we're sitting right around 250, 251 bushels per acre on average, right? So what this shows is that we likely landed on the optimal profitability rate for this field in this year, even though it was a higher nitrogen rate than what the grower typically puts on and by a significant margin. If we look at the Iowa fertigation, the other half of this Iowa fertigation field, this was a previous crop soybean. What we see here is that we had a very similar nitrogen application strategy, but just a slightly lower rate to start with on this field. There was a 30-pound nitrogen per acre rate applied at planting instead of 45 pounds, which accounts for the difference between these two halves of the field. But we came out to a total nitrogen rate of 241 pounds of nitrogen per acre on the soybean half, so roughly a 14-pound of nitrogen per acre reduction. And we saw very similar trends here. So we yielded 240 bushels per acre compared to an anticipated 235 bushels per acre. Typically, this grower would have cut back on one of those late season passes as well and only applied 160 pounds of nitrogen per acre to this field to give a 40-pound legume credit. And again, what we see here is that our lowest nitrogen rate in the field was basically at 211 pounds of nitrogen per acre. There's a little bit of variation in that because we use the as applied data to drive this, right? But that was basically where that low nitrogen rate is. So 50 pounds higher than what the grower would have put on in their typical nitrogen management program. And that yield value came out in those low nitrogen plots somewhere right here in the upper 230s. So we know that in order to get to that yield value of 235 that was expected, we needed at least that 211 to get there. And we likely got a little bit more of a bump with the additional 30 pounds that went onto the bulk of the field. And again, you still see those positive direction trends in terms of yield response to additional nitrogen. Again, this is not typical for what we've seen within time in previous years, but was noticeable this year. And so while the profit numbers suggest that there was lost profit this year, if you really look at where we would have been profitability wise with the standard program and where the standard program would have landed for yield, I think this actually probably comes out in a very positive way from a profit standpoint if we were to adjust how we make that comparison. So any questions on these two fields here, or halves of the same field?
Everybody's quiet this morning.
Yeah, it was a
Said
lot of really good information. Really shows how that your timing and the rainfall makes a big difference. I was looking at a chart that somebody had made in 135 years of rain data. I think we were in the zone that showed it was the 134th wettest year in this area. So out of 135 years, there was only 1 year that was wetter. So that tells a story and the variability of all these plots and how much rain. That rain can really hurt too much also.
Absolutely. It's a good point. Really good point.
that kind of opens the door to a question I was going to ask. Future setting up our high rate checks and that. I assume you want. Do you want to hit as many soil types as you can, or would you rather have a more consistent area?
Yeah, we want to hit as many soil types as we can. So that kind of gets into the next slide I had here, Lauren, which is how do you use this, right? How do I think we need to use this in Iowa as we move into rain fed? If there's going to be one post-planting application, I want to make sure that we've got our plots established at or before planting. And so to me, the plots are the key here. The plots allow us to assess. Later in the growing season, they allow us to calibrate the imagery. They allow us to calibrate the model. So getting those established at or prior to planting is key. So that's one thing. And then in doing that, Lauren, I want to make sure that we're hitting the major soil types in the field. So I'd like to capture 90% of that field area in terms of soil types with those plots, whether that's field link strips that intersect multiple of those zones, like we saw in the Hannah field with the south plots. I thought that worked out great. We could measure really, really well there. Or whether it's putting, 3 plot pairs in specific zones in the field, which is what we see a lot in Nebraska. That could also be a good strategy here, but getting those plots in at or before planting is key if we're going to make that single post-planting application. If we're going to do multiple post-planting applications, we can afford to wait until that first post-planting application to inform the very last one with those plots, but we want to make sure that they're in there before that last post-planting application. Getting data in early, so 2+ weeks prior to plot establishment is going to be key on this. Let's connect software and let's make sure we send in any data that's not connected to the software. And let's make sure we have the imagery and crop model activated at or before planting, right? So that we've got all the information that we need to make a good decision and can make that prescription available daily for any application that needs to be made, which I know we've talked about previously is really, really important to have that prescription available whenever we're able to go.
I would say that was probably the biggest take home this year is just learning the different systems and stuff like that. One question I did think of here, like all mine were randomized blocks based on history of the field, but I see a little bit. I like the actual strip trails. Put the strips because that would be easier with the Y drop and stuff like that. The one thing we learned, and that I think that showed up on that field you used to mine, is the operator better know the high rate plots coming up.
Yes. Yep.
And just blowing down, and I'd still somewhere along the line I'd like to figure out why he came in and filled, why when he went back that application rate was so skewed. I mean, reality says it was right, but it was nowhere near the 400 pounds.
Yep.
And that I would be curious digging in some of my other fields sometime if you got time, because wherever the randomized blocks were on my field, I can't see where the low rate hurt us or the high rate helped us.
We should be able to dig into that. We have a fractional director of agronomy joining early in the new year, so he'll be able to do a lot more of this detailed work while I'm trying to run around and talk to everybody. So he and I will collaborate on that, but I think we could probably get those fields processed Lauren.
Cool. And then one final thing is, I think I heard the other day that you got kind of a good recognition there. AE50, is that was that Farm Journal or?
That was the American Society of Agricultural and Biological Engineers. Yep. Top
So
50 projects.
congratulations on that. And any final questions or thoughts for Jackson? I see we lost a few guys here, but
Just
I'm gonna-
thanks, Jackson, for coming on. I appreciate you going through all that data, and really does explain a lot of things, and a lot of things I wouldn't even have thought of are involved in that. So I think you got a great analysis and how it's proven. So thanks a lot. And Merry Christmas.
Merry Christmas to you too. I appreciate y'all working with us.